Hello, guys. Good morning. Welcome to another session of Blockchain Maths 101. So, yesterday we touched briefly on the basics of blockchain mathematics, and today will be I would like us to review some of the things we did yesterday and get into some of the calculations before proceeding to the next topic for the class. And I would like you to revise and look through the slides I dropped yesterday and get to this part, the basic arithmetic. So for basic arithmetic review, we have addition and subtraction, you know, and I'm not going to touch so much on addition and subtraction because I believe we all know how to do simple additions and simple subtractions. But seeing if you add tokens or subtract or you send out tokens from your account, when you send out tokens from your account to another account, you know you're dealing with subtraction. And then if you the account you sent that tokens to will be dealing with addition. So I don't want to touch so much on that. Excuse me. Let me just quickly. Okay. So please reference the slides because I'm not sure of how to share two screens at the same time. But kindly reference the slide.
Yeah, I think you have it's from your hand. Your screen is visible.
Oh, okay. So we'll be doing basic. So I'm not paying attention to the screen right now. So if there's anything, please feel free to interrupt me.
Okay.
Yeah, so for
So
basic arithmetics and subtraction, let's take the case study of person A and person B. So if person A has 10 tokens And person B has two tokens. So if we say that person A has sent two tokens to person B, it will be that person A 10 tokens minus 2 tokens. While for person B that is receiving tokens from person A will be 2 plus 2 tokens for person B. I want to be sure that we are following. So using arithmetic and subtraction helps you to check for balances. Now we know that the current balance for person A is now 8, while for person B is 4. Because when you do 10 minus 2, you get 8. And when you do 2 plus 2, you get 4, right? Now, this is just the simple arithmetic subtraction. I was trying to explain to you that I will not dwell much on. But let me just explain a little bit of context to this. When you're writing your smart contracts, when you are creating your logic, when you are doing anything, you have to be sure you are capturing this because the smart contract is as smart as the developer. The smart contract is only as smart as the person building it. So you that is building your writing your smart contract, if your logic is faulty, your smart contract will be faulty and it will be susceptible to vulnerabilities. So when you're writing your logic for your smart contract, you need to handle this properly. The smart contract does not know what person A's account balance is or person B's account balance is. You need to handle it that if person A sends two tokens to person B, it should handle the fact that person B's tokens will increase. You get that? It should handle the fact that person B's token is going to increase. And it should also handle the fact that person's A tokens will decrease. If you do not handle those facts, if you do not handle those scenarios, those case studies, your smart contract will be faulty and vulnerable. So, for example, when after person A has done this transaction, in normal mathematical state, we believe person's A balance to be 8 and person's B balance to be 4. But in your smart contract, you need to specify this because to the smart contract, person's A balance is still 10 and person's B balance is still 2. So you need to handle this for the state to make changes for it to write to the blockchain. So after you do this subtraction, let me show you the proper way to handle it. So you need to know this for your logic. If person A 10 minus 2, A balance should be equal to, you have to now fix the balance yourself, should be equal to 10. What the current balance is, you can just put the current balance, knowing that the current balance is actually 10 minus 2 tokens. It is after you handle this fact that person A's balance in your smart contract will actually be 8. Now person B balance, according to the smart contract, is still being 2. even though the transaction has happened. But so you have to handle the balance yourself. So this balance now will be equal 4. Now, the mathematics here has easily done the subtraction and the addition for you. But once you are dealing with your smart contract, you're dealing with your smart contract logic, you need to understand what happens, how these things happen. You need to look out for the results you are expecting, and you need to program your smart contract to operate according to the result you are expecting to get from it. Okay. I hope this is very, very clear to us listening. Unfortunately, I cannot interact with everybody at the time. So now sorry, let's go to the multiplication part. So in your slide,
Like, if you have a question, you could just quickly ask. So we have some of the students here.
okay, okay, all right. So we're going to multiplication and division. So the example in the multiplication and division part is the transaction fee is 0.1 tokens per unit of data, and a transaction has 10 units. What is the fee? So the transaction has 0.1, uses 0.1 for each unit of data. So if we have 10 units of data, how much how much is going to be used up? If 0.1 is used for each, how much is going to be used up for 10 units of data? So we are looking for this value. What you would do normally is to have a multiplication, right? Where you do 10 times 0.1,
One.
yeah, and it gives you 1. So in the normal scenario, what is happening is that when when you have used 1 unit, it will deduct 0. Sorry. When you use 1 unit, it will deduct 0.1. What is going on with my hand today? It deducts 0.1. When you use 2 units, it also deducts 0.1. Use up 3 units. For each of the units you use up, 0.1 keeps deducting. So when you have used up to 10, when you have used up to 10, you add you add up all the 0.1s for each of the level, for each of the steps, it will give you 1. So that is the breakdown, right? So in understanding this, you need to understand what is happening behind the scene. And this is what is happening behind the scene. That for every step where a unit keeps getting added, plus 1, plus 1. For each of these steps, 0.1 is getting um, subtracted from it. So hope we get this clearly. Hope we understand this properly. So you need to understand what is going on behind the scene so you know how to program your smart contracts to behave in this manner and not just trust that whatever logic you gave it, it is smart enough to just pick that logic. The smart contract is smart as you, the dev, writing it. Okay? All right. Introduction to exponents. You can go to that part of your slide. I said yesterday that exponents or powers represent repeated multiplications, right? While not always obvious, they appear in understanding token supply, growth, tokenomics is an important area that uses exponents. So you can calculate amounts at different times, like token supply growth, long-term projects, understanding compound effects. Now let's do a bit of the token supply growth. So let's call this token, sorry, let's call it FVMT. And let's start FVMT with a total balance of 100. And now FVMT increases in 100% every year. So we say FVMT increases the decision and the strategy for FVMT is that it increases in 100% yearly. So now, having this knowledge, how much will FVMT total supply be in 4 years? Does anyone want to give it a go? Does anyone on the call want to give it a go?
Yeah, guys. Your attention to there. Yeah.
Okay.
Does anyone want to give it a go?
Just unmute yourself and respond. Unmute yourself and respond.
Who is speaking? Can you please come closer to the mic?
Come to that.
Alright.
That'll be 400 FMC.
Okay. Does anyone else want to give it a go? All right. Thank you. Thank you so much for the guy that.
If it increases by 100%,
Hmm?
it should be 500. It should be 500 FVMT.
Should be 500 FVNT.
Yeah, if it increases by 100%, no, not actually no. If it increases by if it
Now this
relax,
is
chill. If
interesting.
it increases by 100% every year, By the next year, it
Mm-hmm.
increases by 100. In the next
Mm-hmm.
2 years, it increases by 200. In the
Mm-hmm.
next 3 years, it should increase by 400 actually. Then in the next year, it should increase by I can't just quickly run that calculation, but that should be the
Okay. Thank you. Thank you for that. Thank you. Is anyone else trying to give it a go? All right. Let's just go quickly. So we have FENT at 100 total supply, and it increases at 100% yearly. How much FENT total supply will be available in 4 years' time? So now this is in normal mathematics, I think we can call this word problem. But this is really a world problem because this is something you're trying to solve. This is something in life, in the world of business, in the world of transactions that deals with humans that you're trying to solve. And you're trying to remove every form of vulnerability. Now, going with the first person's response, he said it will be 400, and I'm sure his logic was like every year you add 100, 100 plus 100 plus 100 plus 100, which eventually will amount to 400. But is this the reality of the case? Is this the real scenario of what happens? No. And that is why we are dealing with exponents. Now, every year there's 100% increase, and 100% means the the total supply as at that point. 100% means that that total supply is added to itself again. So if we had 10 pieces of oranges and you say 100% of the oranges was added, that means another 10 pieces of oranges were added to the previous 10, making it 20. So for the first year, our total supply will increase itself because it is 100%. So it will be plus 100. So after the first year, you have 200 tokens, right? After the first year, the second year, you have the 200 tokens. Now, sorry, for the first year is 100 tokens. So now for the second year, it will be 100 plus 100 because that is the percentage. That is what 100% means, the 200 tokens. Now for the third year, why is my writing this bad today? For the third year, we'll check our current token supply, which is 200, and add 100%. And 100% of 200 is 200, right? And then you get 400. And then by the fourth year, 400 plus 400, you get 800. Now, what just happened here? What just happened here is that using this method, we have said that the first year nothing happened. There was no token increase and blah blah blah. So we have only 100. The second year we did 100% on the first year and you got 200. The third year you did 100% on the second year and you got 400. While the fourth year you did 100% on the 400 and get 800. Now, is this correct? Is it the actual scenario? Is it the actual state of things? Is this how things are supposed to be? Then let me give the third scenario. For the first year, we already have 100 tokens, and we say at the end of each year, in each year, these tokens should multiply. So starting from the first year, you add, you multiply, then you get 200. So at the end of the first year, your total supply increases. At the end of the second year, you have 200 plus 200. At the end of the third year, you have 400 plus 400. At the end of the fourth year, you have 800 plus 800, which gives you 1,600. So what case scenario, guys, do you think is the correct scenario? This is the first, this is the second, this is the third. So in which of these scenarios are we correct? Did we get our calculations right? You can unmute your mic and speak, or you can type that in the comments section. All right, so in order not to waste much time, what is going on here is that for this first scenario, you just did a basic addition each year of 100 tokens. And that is not the true state of things, because at the end of the first year, your token should have multiplied, should have increased in 100%. So whatever your tokens was, it should have doubled by the end of the first year. At the end of the second year, it should have also doubled. So if we use this method, you are just adding 100 to this, and that is all. And now, in this second scenario, basing on our judgment that at the end of the first year, we still have 100 tokens, it's still wrong, because at the end of the first year, we are supposed to see an increase in token supply. Now, this is the correct scenario where you have 100 plus 100, it doubles at the first year, doubles at the end of the second year, doubles at the end of the third year, doubles at the end of the fourth year. So in 4 years' time, you are supposed to have earned 1,600. The total supply of tokens are supposed to have increased to 1,600 in total supply. So this is the correct scenario where everything gets added together, starting from the first year. Now, in normal mathematics, we can use the formula where when you're calculating exponents, you pick the principal or the initial item, uh, uh, the initial amount, and then with the mathematical formula, look through the exponents in the example. Yeah, okay. Is somebody trying to speak? I like the mic got unmuted. Okay. So in normal mathematics, it will be since the item doubles, right? That means it adds itself times 2. You want to raise it to the power of 2 times how many years it runs. So this runs for 4 years, first, second, third, fourth year. And what happens is that it doubles every year. So it adds to itself twice. So this is 1, this is 2. If it adds to itself 3 times in every year, then you are raising it to the power of 3. Okay? If it adds to itself 4 times every year, you will be raising it to the power of 4. So this is a simple explanation in mathematics. And when you do 100 raised to power 2 times 4, it's going to give you around 1,600. If you do your calculations, you should get this. Why did I break it down this way? I did it this way for you to understand what goes on, what really happens in each year, in each step of the way. You need to understand this in order to program your smart contracts. Because, like I said, a smart contract is only as smart as the dev that built it or as the person that deployed it. You don't want to deploy a vulnerable smart contract that hasn't handled the different possibilities, the different scenarios, the different edge cases. You need to understand the math that is going on behind the scene and also check to make sure that it is happening as it is meant to. If not, your smart contract will be vulnerable to a lot and a lot of issues. It can be hacked. Imagine writing a smart contract for a protocol that deploys their tokens and they are running their business, and then there's a faulty logic in the smart contract that gets exploited, and they lose a lot of money from that exploit. Do you know who they are going to hold responsible for that? Is the developer who built it, because you did not do your due diligence to check out um, all faulty, every form of vulnerability from your logic. So that is why it is important to understand what happens behind the scene and not just take it like going straight to 100 raised to power 2 times 4. Whatever it gives you is whatever it gives you. You need to understand what is going to happen every year, because that is real life. This is what is really going to happen in the physical world, not just on paper, not just in code. So you need to understand how it will happen. And if the test is not giving you the real scenario, like when we tested this and we checked for it, at the end of the day, we realized that it's not giving us the correct scenario. This is a vulnerability that can be exploited terribly. Why? Because every year your supply is supposed to double, right? But your supply is supposed to be double of what the current supply is, but it isn't. And if your logic was that that should happen and then it only adds 100 every year, what happens to the rest of the tokens? The rest of the tokens at this point can be hacked, and the balance of the tokens that are supposed to be added can be sent to a hacker's account, a different wallet, because they realize there's a vulnerability in your code. Like a lot of scenarios can come up from this alone, and nobody will actually know from the code that this is what is wrong if they do not pay attention to the logic. But anyone that is smart enough to pay attention to the logic can hack this, knowing that they are expecting this at the end of the year, this is what they will get. But then the logic is for this type of scenario. At the end of the 4 years, they made 400. What happens to the rest 1,200 tokens? Where is it? You will not get it back if it is being hacked. So these are things you should check for. Now, also for this first year, the same thing will happen. What will happen to the balance? Why is it not 1,600? And then you'll be explaining. You explain tire. So understand the math that goes on behind the scene so you can write your test cases, check for all these scenarios, what happens, what is your actual result, what is the actual expectance of this logic at the end of the day, and make sure that your result is actually equal to what is expected. If it is not equal to, then your logic is wrong. There's a fault in your logic you need to fix. All right, going to the next. Uh, the next is introduction to basic algebra, variables, and simple equations. Algebra introduces variables to represent unknown values. These variables are often used in transactions and smart contracts. Solving basic equations helps determine these unknown values, enabling the execution of instructions in smart contracts. So when we talk about variables, variables are not fixed. So variables are like placeholders you put in place of a value or something for future purpose or to just hold down a value. Now in algebra, these variables are used to determine to how will I put it? These variables are like placeholders for a value that is not yet known. So when a value is not yet known, these variables are put in place as placeholders, like solving for x. X at that point is a variable because we don't know what x is, but we want to solve for x to get the value that x holds. So at the end of the day, sorry, excuse me. Okay, so at the end of the day, at the end of the day, we want to get the value that has been associated with x all the while. And so at this point, x is the placeholder for whatever value we're going to get at the end of the day after solving for x. So x is a variable, x, a, b, c, and whatever you put in that place are called variables because they are representing unknown values, they represent unknown figures. What is going on? Sorry. Simple equations like solving linear equations, you have x plus 5 equals 10 and stuff like that is where all these variables are put in place. Um, so variables can take different forms. When you say 2 plus 2 is equal what? So this is a variable. You have to do this equation. You have to solve this equation to get this, right? Another form of variable can be x plus 2 is equal 5. And now, how do you know what x is at this point? You have to solve this equation to know what x is. You need to solve this expression to know what x is. It can also be 2 plus this equals 8. How do you know what this is? Y is. You need to solve this expression to get what y is. It is very easy when we know what these two figures are. Initially, when we solved for person A and person B, we knew what um what person A's balance was, and we knew how much tokens left person A's balance. But what if we didn't know, we weren't aware of what person A's balance was initially, and we subtracted 2 from it, and then we finally got that the balance at after subtraction is 8. How would this have been represented? If you didn't know what person A balance is, it would have been maybe balance minus 2 will be equal to 8. So this is a representation in an expression where you do not know what a particular value is. You represent it with a variable. I just hope that is clear enough for us to grab. All right. So let's work on the example in the slide. If a smart contract pays out X tokens, smart contract pays out X tokens. What else? And the total payout is 15 tokens. And someone else received 7. How much is X? So we said a smart contract paid out X tokens. Sorry. A smart contract paid out X tokens. The total payout that happened on that smart contract was 15. And someone else received 7. But now we've established that the total payout is 15. So you can represent this statement in an expression. The first payout the smart contract did was X. We do not know. And the second payout the smart contract did was 7, right? But one thing we know is that we also know that the total payout that was done is 15. So we know that whatever X is plus this 7 that the smart contract sent out, they are all added together to get the total payment, the total payout. Now we know what the total payout is, and we know what someone got, but we do not know what the previous person got, which is the X tokens. And that has led us to writing the statement as this form of expression. How do we get X?
I think the question here is actually how many persons. No, I'm not muted. Your network is slow. How many persons was was the payout made to?
Okay.
Like how many persons was the payout made to? Because the question here says X tokens was paid out, and the
Mhm.
total payout. This total payout, is it the total times a payout was made, or the total amount of tokens paid out? Then someone else, out of how many persons? I think that should be the right way to actually figure out what we're actually working with. Does that make sense?
No, 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 no. What is going on here is a smart contract pays out X tokens. Please kindly listen
Hmm.
to all the keywords in
Yeah, that's what
a,
that's
yeah.
what I'm trying to
So
figure
it
out.
pays out X tokens, and the total payout is 15 tokens. So it is
Okay,
clearly
15
stated that
tokens.
this is tokens, not persons. You
Okay,
get.
okay,
Then
okay,
someone else received 7. So in the first instance is that he paid out X. The second instance is that he paid out 7. Regardless of how the statement is coined, it can start with a smart contract made a total payout of 15 tokens.
Mm-hmm.
It paid someone 7 tokens and sent out X tokens. Find X. So it can go in any direction. But it specifying tokens in the total payout lets you know that this is what we are actually solving for.
Is it
Okay.
is is it not crucial to know how many persons the tokens were distributed to?
So you can see that this smart contract pays out X tokens, right? The total payout is 15 tokens and someone else received 7. How much is X? We are not looking for the person, we are looking for the X. Are you getting the question?
I get you.
Okay. So we are not looking for how many people got these tokens. We are just looking for how much was
He said someone
distributed.
got 8
We know
and
how
another
much was
person got
distributed,
7.
but we don't know what was the first distribution before the 7 happened. So that is what we are solving for. This X in the example is what we are solving for. Thank you. X is 8. Simon, thank you for that. Now, how do we solve for this? We, as at this instance, we are solving for tokens, guys.
He said
We are not
they
solving
get like
for
they
people that got
they have like
X.
15 people of that token. They give someone got X, another person gets
Okay. All right. So, what do we do in this scenario when solving for X? Using the normal mathematical statement, we know that when you're trying to solve for a variable, you move all the items with values to the other side of the equation, right? You check your left-hand side, you check your right-hand side, left-hand side of the equation, right-hand side of the equation, which part of the equation has the variable. The left-hand side of our equation has the variable x. And to solve for x, we need to move every other item that has a value over the equality sign to the next place. Now, moving this item, at this point, we are not moving just 7, we are moving plus 7 from here. And when plus 7 is moved from here to this side of the equation, because it has made a jump over the equality sign, it turns from, the sign turns from plus to minus, because it is moving this over the equality sign. So the next thing for you to do is to move it over from here to here. And so we say x is equal 15 minus 7, or x equals minus 7 plus 15. Now, once you have done this valuation, x at this point becomes 8. When you've gotten x as 8, you come back to the statement and replace x with 8. So we say 8 plus 7 should give us 15. If this is correct, that means, if this statement is correct, that means x was originally 8. So the smart contract has disbursed 8 tokens before it disbursed the next 7 tokens, since we know what the total tokens um, is that has been disbursed. So at the end of the day, 15 is equal 15. Now, is 15 equal 15? True or false? Is it true that 15 is equal to 15? Or
True.
is this
True.
15 here greater than
It's
15
true.
or lesser than 15? So it is true. So this statement pass. Now in your smart contract, you know why I am doing all these things and like wasting your time to explain some key parts of this. It's for you to understand what happens behind the scene. Okay, so your logic would follow that pattern. At this point, when you find x and then you move it over here, your logic must carry the fact that this sign is no longer a positive sign, but is a negative sign that is coming over here. And once you do your equation, at the end of the day, you get x is equals 8. You have to check. You have to create this check. This check in your normal mathematics will not happen, right? Once you have found x, it ends there in your normal math textbook, right? You do not need to do this check any longer because you already know. But in your smart contract, you cannot um jeopardize with this. You need to make this check to be sure that whatever x got, if you add it to the other value at the right hand side, it gives you exactly what is expected. If this does not give you exactly what is expected, your logic is wrong. Your logic is vulnerable to attack. Then you get your final statement, and then you check that whatever is gotten here is directly, which comes with um, double equation, is directly equal to what is at the right hand side. So once your checks you are triple sure of your checks, then your logic is correct. So this is how to do some simple um, uh, algebraic equations in your smart contract. All right. Okay. So the final slide is transaction fees, tokenomics example. A token has a total supply of 1,000. So we'll break it down this way. It has a total supply of 1,000. And 20% is allocated to the team. 20% is allocated. Now, 20% of what? Now, these are the kinds of questions you should be asking. 20% is allocated to the team. How many tokens is that? How many tokens is that? Is a different question from how many tokens is left. How many tokens is that? That means we are solving to know how many tokens was allocated here, where 20% was sent out. And 20% of what? 20% of the total supply, which at this point is 1,000. So to represent this properly, we are saying in a more mathematical way, we're saying 20% of 1,000 tokens, total supply was disbursed. How much tokens was disbursed? So I think this is a much more clearer, streamlined way. Now, what is 20%? 20% is 20 over 100, right? This is the illustration, the definition of 20%. It's a 20 over 100, and it's of how many? It is 20%, 20 over 100 of 1,000. You want to get how much tokens was distributed. You times the 20% by 1,000 to get how many tokens was distributed. So now we have 20 times 1,000 over 100. You can either go through that method. There are different ways to do this. You can say 20,000 times 20 by 1,000, 20,000, sorry, over 100. So using this method, you can just easily cancel. 20 times 10 gives you 200. In this scenario, cancel, you get 200. So any way you decide to write your logic, you can either just remove immediately, or you can times it together and remove the same thing that happens. Now you get 200. Okay. So 200 was the token that was subtracted from the total supply at the end of the day. So for this, you have solved the equation by knowing how much was gotten was or how much was deducted was 200. Now for the mathematical equation, this is okay, this is perfect. But for you writing your smart contract, you need to understand, you need to understand how much is left once the 20% was distributed. How much is left in your total supply? How much left after distributing 20%? 1,000 minus 200 is equal 800. Okay. Now this is not the full picture, and that is why we are not seeing some other variables in play here, because we are not solving for how much is left, right? So 1,000 minus 200 gives us 800. So this is the balance. This is the balance, the current total supply available. No, the total supply is still the same total supply, but from wherever it was disbursed from, this is what the balance is supposed to be from the particular wallet it was disbursed from. So once you have got, you know this is 800. If the question already knew the balance, what you have done is to make sure that 1,000 minus 200 gives you 800. 800 in comparison to the current balance, which is supposed to be 800. So once you compare this 800 you got from here and this you got from here, and it equates to true that 800 is equals to 800, then your smart contract logic is correct. Unfortunately, we cannot solve for that because that is not the question. The question is to determine how many tokens were distributed. Now, there's something I need to make clear to you. When you are talking about total supply, right? Total supply in the context of tokenomics or tokens does not reduce unless there is a burn. Okay? Unless there is a burn. So in the context of total supply, let's say we have 1,000 tokens in total supply, and maybe this is the official wallet address that held it. Depending on the logic the smart contract holds, either wallet address or maybe it uses a mint function to mint to each address that clicks on a particular thing. So let's say the wallet address was holding the entire 1,000 tokens. So it is this wallet address in the context of this, after 20% is disbursed from here, it is only this wallet address that gets the balance reduced. So you say 1,000 minus 200 is now 800. So for this wallet address, it only has 800. But for total supply is still 1,000. It did not reduce because you did not burn this 200. All you did was to send this 200 to another address. So total supply will still add these tokens here plus the tokens that are still here to still give you 1,000. But once this 200 is burnt, it's not in supply anymore. It is not in the ecosystem, it's not in the economics anymore. Then total supply is going to reduce. And then your total supply becomes 800. But in this scenario of what we just solved, total supply remains 1,000. It never reduces. It is just the balance in the wallet that holds that 1,000 that has reduced. So hope we are clear with this, and I think I'm done with the slide. Do we have any questions? Hello, guys. All right, if there are no questions, I've come to the end of today's class. Thank you, Adasa. I've come to the end of today's class. Thank you, guys. Enjoy the rest of your day and prepare for your next class by 10 a.m. Bye from here.
All right. Thank you. Can you hear me? Yeah, guys. That was a very nice session, and so you have all what you take to have a great startup today. So we'll be having more hands-on today from 10 a.m. Um, so get set. At this point, we'll be going for a break, have breakfast, and then let's assemble by 10 a.m. Thanks you once again for it, and see you later. From this, for for virtual participants, yeah, check out the Telegram group and do all the tasks it asks you to do. From our decks, we're saying GM.